Hi everybody. Today we're working on figuring out the relationship between volume and pressure when working with an ideal gas. In class, you collected data very similar to the one in this simulation using our vernier pressure sensor probes. Notice that the simulation does this rather quickly so that we can get some sample data for our Excel spreadsheet. The simulation I'm using is from a professor at Iowa State University who makes a bunch of simulations for chemistry. As soon as we've collected enough data to give a pretty good curve on an Excel graph, we'll plot these points in Excel. Notice that I accidentally collected a little bit of data that's actually outside the parameters of that particular pressure probe. Try not to do that in class. Okay, now you'll see that I have entered all of these data into my Excel spreadsheet. This is what you guys need to do. If you need to, go ahead and pause the video so that you can follow along. As soon as you've entered all your data, make an XY scatter plot. Those are our new favorite kinds of graphs. And you'll see that the relationship between the volume and the pressure looks a little curvy. Let's clean up this graph a little bit. Get rid of those lines in the back and that silly series thing on the right. Add some labels. Now if you have the PC version of Excel, it's going to look a little different than mine. Mine's the Mac one from 2000 and something. I'll add some labels on the bottom. Our x-axis is volume in milliliters. And for the example of our simulation, the pressure is recorded in the units of pounds per square inch. I believe your verniers record in kilopascals. Use that one in your graph. Okay, add a title. We're going to have volume versus pressure for this. Now one of the things that makes Excel pretty cool is that you can adjust your axes. Notice that there's a lot of space between your start of your axis and your data, so we can go ahead and change that a little bit. Just make the minimum amount a little bit smaller than whatever is in your closest point. That way we can make it look nice and pretty. Now to actually analyze this data, we're going to need to add a trend line. You can do that by right-clicking one of the dots in the data. Choose the right shape. For pressure versus volume, the power is actually pretty good. You also want to make sure that you show the equation on the chart, and you want to show the r-squared value. Remember from last time that the r-squared value shows you how close your data is to the equation that the computer is generating. Because we got this from your simulation, we're going to have an r-squared value of 1, and it's going to be perfect. You also notice in our equation that the relationship between the x and the y is inverse. You'll see the -1 on that x. So you'll notice that whenever the volume increases, the pressure decreases, and whenever the volume decreases, the pressure increases. So noticing this pattern, I want to redo my data. I'm just copying and pasting my pressure data, or rather the volume data, and we're going to change the pressure data so that it is 1 over the pressure. That way we can see if we actually have a kind of linear relationship. Now the way I do this, now that might be a faster way, and if you find a faster way, let me know and I'll give you a little extra credit. But what I did is I hit the equals button and then 1 divided by, and then I'm just going to click the cell that my data is in. It ends up being pretty fast. I copied the equals 1 divided function so that I could use it over and over really quickly. Now this will take a little bit of time, but not more than a minute or two. Notice in each of the cells I'm pasting my equals divided by, and then I'm just clicking the cell with the pressure that I want to change. Once you get the hang of this, it actually goes pretty fast. You kind of get a muscle memory thing going, and the data goes faster and faster. Now we're almost done. Just 2 more points. Oh, finally. Okay. So now we have this new and improved relationship. We have volume and 1 over pressure. I'm going to select the data, and then we'll make another graph. Select XY scatter plot under the charts, and now we're going to beautify this wonderful line. Look at how pretty it is. Your data will probably not be exact because you're going to collect real data instead of the simulated data. But you'll do the same things. We'll make sure that the graph has labels on each axis. The y-axis in this case is 1 over pressure. Notice that my units are 1 over psi, pounds per square inch, but yours are going to be in kilopascals, or rather 1 over kilopascals, and that your volume unit stays the same. It's just milliliters. We'll also remember that all good graphs need to have a title. This one's going to be volume versus inverse pressure. Now we'll fix our axes to make them look pretty. Make sure that we are emphasizing the actual data. Remember, you can just right-click the data. Oops. If you accidentally double-click, you'll get a weird option menu. Just right-click the data and change the axis so that it focuses on your data. Now let's add a trend line. I can right-click my data, click Add Trend Line. We're linear this time instead of a power. And I'm going to make sure that I remember to click Show Equation on Chart and show the R-squared value. Now this is our really important graph. Notice if you go back to the home part, you can adjust the size of the font in your graph. You can also make your graph bigger before you take a screenshot of it and put it into your lab report. And at this point, we're pretty much done, and you're ready to think about how we can show this as an equation that's simplified for our lab report. I hope that this video was helpful.